Right, so how do you factor and simplify? So there's no question how do you factor and simplify? There's no really a question here, it's more of a concept. Let's look at the solution. So let's start off with this example because this is kind of what the solution attempts to solve. So I'm assuming this is kind of what the question is asking. So let's say we had an equation as follows: sine 4x minus cos 4x. Okay, so, and we're trying to figure out how can we simplify this down. So because we have a minus sign in the middle, we can see that this is a difference of squares. I'll clarify that by just rewriting this equation in a more simpler format. So we would have sine squared x squared minus cos squared x squared. So because we just kind of expanded it out, we can see now it's a little more clear why this is a difference of squares. And the equation that we would be using is this one, the one written on the side here. So a squared minus b squared is equal to a minus b, a plus b. So that's just the difference of squares equation. So moving on, we would get the following. So we would get sine squared x minus cos squared x times sine squared x plus cos squared x. Okay, so here, if we were to represent a and b values here, a would equal sine squared x, and b would equal cos squared x. And then when we're splitting them out, a and b, we have sine squared minus cos squared, and then a plus b again, so sine squared plus cos squared x. So using trig identities, we know sine squared plus cos squared, this just equals 1. So this kind of simplifies down. And we're left with just this component. We have to think of a trig identity that can help us simplify this down even further. So we can rearrange this to equal cos squared x minus sine. So we just factored out the negative in the beginning. Okay. And the trig identity that we have here is cos squared x minus sine squared x is equal to cos 2x. So actually it's not 2 cos, I believe it's just cos 2x. So let me just double check this. So usually you have a trig identities table that is useful to remember all the trig identities. Let me just pull one up right here so you guys can take a look. Just give me a second here. All right, so here We can see cos 2 theta over here. So cos 2 theta is equal to cos squared theta minus sine squared theta. So that's the trig identity that we're using to simplify. Okay, so getting back to the question, we'll end up with negative cos 2x. I'll put this in bracket just so it's clear. So you can't simplify this down any further. That's kind of your final answer. So let's just double check the solution over here. So yep, they come up with the same final answer, negative cos 2x. Okay. So I believe here they provide another example. So instead of sine 4x squared, sorry, sine 4x minus cos 4x, they say cos 4x minus sine 4x. So it's also a difference of squares. So following a similar process, you can eliminate the cos squared x plus sine squared x. This is equal to 1. And then you end up with this, except you don't need a negative sign in the beginning because it's already in a format where you can convert it to cos 2x. So here's another example. So cos squared x plus sine squared x to the power 6. A very important trig identity to remember is as follows. Probably one of the most important trig identities. Oops, let me just write that up here. So sine squared plus cos squared equals 1. So whenever you see cos squared plus sine squared or sine squared plus cos squared, you can right away say that 1 to the power 6 is just 1. So see here, simplify 1 to the power 6. 1 to the power of anything is just 1. And we get that answer. So correct explanation and examples. Good job.